All right, so these are notes on lipids. And again, I assume you've already watched the notes on introduction to macromolecules and then also carbohydrates. So lipids, just like carbohydrates, can be broken down to supply cells energy. And if you remember back from the introduction notes, they actually supply more than twice the amount of energy as carbohydrates with the same mass of substance. So 1 gram of lipids supplies more than twice the amount of energy as a gram of carbohydrates. And the same with proteins. Proteins and carbohydrates are pretty similar. Lipids are more than twice the amount of energy. Lipids also can make up cell membranes. So of all plant and animal cells have a cell membrane, and lipids make that up. And I'll show you a little later a really great device you can use to remember that. And then they also can help make hormones as well. All right, so first we want to look at what are called fatty acids. Fatty acids are chains of carbons and hydrogens. And there are two kinds of fatty acids which you've probably heard of in your day-to-day life. So one is a saturated fatty acid and one is an unsaturated fatty acid. So if you take a look at the saturated fatty acid, you'll notice that the carbon-hydrogen chain here is all single bonds. And when it's all single bonds, that allows the maximum number of hydrogens to bond. So carbon, remember, can bond 4 times. So if we're looking at this carbon here, it's bonded once to this carbon there. It's bonded once to this carbon there. Then we've got 2 hydrogens, meaning it's bonded once to a hydrogen and another time to a hydrogen, and it's used up all of its bonds bonding to other elements. In an unsaturated fatty acid, you'll notice we have some double bonds. Not all throughout, there's still some single bonds here, but that means, for example, if we look at this carbon here, this carbon is double bonded to this carbon is, and then single bonded here, and there's only 1 hydrogen. So when we say saturated, remember that means you've dissolved as much stuff as you can and the solution is saturated. When we say saturated fatty acid or saturated fat, we mean having as many hydrogens as you can have. So no double bonds. Versus unsaturated fatty acids, where you do have double bonds, and so you don't have as many hydrogens. And what it does in the end is it actually, even though these look like they're the same shape, they're not the same shape. So if you remember back to carbon dioxide and water, the water was bent, whereas the carbon dioxide was more linear, more straight. A saturated fatty acid is much more of a long line. It's more of like just a chain, whereas an unsaturated fatty acid, because of the bonds, the double bonds, it's not one long chain. It's kind of bent at certain places like the water was, and that results in different interactions in your cell. Saturated fatty acids can sort of all line up together and stack on top of each other, whereas unsaturated fatty acids can't do that. And that's why our body uses them differently and experiences them differently. And saturated fats tend to be, you can put it in quotes, the bad fats, and unsaturated fats tend to be the good fats. And that's what it has to do with it. It's the overall shape of the molecule. So, whoops, I forgot to hide that picture, but that's okay. So, what fats then are, first of all, when we say fats and oils, when we say fats, we're talking about these things called triglycerides, and we'll talk about what those are in a minute, but from animals. And when we say oils, we're talking about the exact same thing, but from plants. And that said, animal fats tend to be saturated, whereas plant oils tend to be unsaturated. So that's why something like an olive oil is better for you than butter, because butter comes from animal fats, so that's going to be saturated fats. Olive oil comes from a plant, and so that's going to be unsaturated. But when we're talking fats and oils, the main difference is, did it come from an animal or did it come from a plant? And so whether you're talking fats or oils, those are structures called triglycerides. Tri, of course, meaning three, like tricycle or triangle. And it's three fatty acids bonded to a glycerol molecule. And we often will have a diagram that looks like this, where this is our glycerol right here. And then here, just like on the previous slide, you saw those fatty acids. Here are our three fatty acids. 1, 2, 3. And one thing to remember is that fats and oils are nonpolar. And that's because of these long chains here, and these are nonpolar chains. And so then I knew people would want to know, like, well, what actually is glycerol besides this box that you have here? So this red part here, that's the glycerol. And then this is called a carboxyl group, if you care. And then we have the fatty acid. So this is a triglyceride. And it's nonpolar. And if you remember, that's why we have trouble washing it off with water, because water's polar, and so we need to use our soap. So then we also have phospholipids that make up cell membranes. And phospholipids have a polar phosphate group, which is the head, and a nonpolar fatty acid, which is the tail. Generally, two nonpolar fatty acid tails. So this is the head part, and that's what's called a phosphate group, and it has a negative charge on it. It's actually quite negative. If you remember back to ions in 7th grade, you had ions that had like a 2+ charge or a 2- charge. Phosphate actually has a 3- charge, so it's quite negative. And then you have this part. So even though the fatty acid is nonpolar, because of this really polar head, you get an interesting thing, kind of like soap. Do you remember soap had a polar head and a nonpolar tail? Same thing here. A phospholipid has a polar head and a nonpolar tail. And then this is a picture of a cell membrane. And what a cell membrane is, whether it's in a plant or an animal, and don't worry about all of these other little molecules and weird structures. We'll get to that. But here is the polar head, and then here are the nonpolar tails, and those are facing each other. So the way I always remember it is I take my hands and I spread my fingers out and I face them together, and then I kind of interweave my fingers together. And I think of that as my phospholipids making up my cell membranes. And so those tails are on the inside and the heads are on the outside. And one thing to note is, this is kind of interesting here. This says the hydrophobic region, phobic meaning fear of. Remember that these tails are nonpolar, so they don't mix with water. So this is a hydrophobic region, meaning on the inside, like between the layer here. This whole thing is the cell membrane. This would be, say, the inside of the cell down here, and this is the outside of the cell up here. But on the inside of the membrane, that's hydrophobic, whereas on the outside, you'll see here, that's hydrophilic. That's water-loving regions, because that part is polar. So that's just kind of an interesting thing. So feel free to add your questions to the comment section. And then the last one you have to watch is proteins.